Hello, everybody. In this lecture, we're going to be talking about carbohydrates, and some of the topics we are going to discuss are the unique characteristics that we see in carbohydrates, what are the advantages of using carbohydrates as a fuel, and what are the mechanisms by which carbohydrates are thought to allow us to exercise and aid in our performance. So, what are the advantages of using carbohydrates as a fuel? And before I move forward, you'll notice that I am abbreviating carbohydrates as CHO. And, that's kind of a universal abbreviation for carbohydrates because of the chemical composition. So, you'll notice that carbohydrates include a carbon, hydrogen, and oxygen element to each of them. And so we will use CHO as an abbreviation. So if you see that anywhere, we mean carbohydrates. Okay. So what are some of the advantages of carbohydrates as a fuel? It's the only fuel that we can use anaerobically. So again, in our last unit, we talked about the energy systems. We talked about kind of those three different pathways that we can use. And carbohydrates are our only option as it relates to a fuel source in those anaerobic pathways. So that ATP PCR system and also that lactic acid or anaerobic glycolytic system can only use carbohydrates as an option. Number two, it uses oxygen more efficiently than fat. So again, when we're doing high intensity exercise, we have a limited capacity to take in and utilize oxygen. So we want to use our most efficient form of fuel available, and that is in fact carbohydrates. So when we're doing kind of like high intensity exercise, that's the greatest bang for our buck. And lastly, it's a faster means of getting energy. So again, if we need energy like pretty fast because we're doing something with high intensity, or maybe we're super depleted and we need to get those calories to our muscles right away, carbs are a great option for that. Okay, so when we think about the use of oxygen per molecule, we can get about 5.05 calories of carbohydrate per oxygen molecule compared to 4.69 calories of fat per oxygen molecule. So again, just a more efficient usage from a metabolic perspective in comparison to fats. Okay. So when we think about carbohydrates, we know that they are uniquely important for three different functions within the body. Number one is red blood cells. Number two is the nervous system. And number three is high intensity exercise. Okay, so when we think about red blood cells can only function anaerobically. So what does that mean? It means that our red blood cells that are floating around in our blood and their job is to carry oxygen to kind of all the tissues and all the locations of the body, they are going to be exclusively anaerobic. So we have to fuel them with carbohydrates in order for them to maintain their normal physiological functioning. Okay. Number two was the nervous system. And similar to what we see with red blood cells, our nervous system has to rely on sugars as a fuel source. So again, when we think about, brain and kind of the efficiency of that nervous system, it's really important that we're fueling appropriately with carbohydrates and kind of have those available so that we can optimize kind of our brain health, but also our brain functioning at any given moment. And lastly, as we mentioned, high intensity exercise. We know that carbohydrates are going to serve as our primary fuel source or our only fuel source in the ATP PCR and anaerobic glycolytic pathways. So it's really important that we have those fuels available if we plan to do high intensity exercise. Okay. The major function of carbohydrates is to supply us with energy. It's also important in forming cell membranes. So we have what's known as glycoproteins that are going to serve as receptors and regulate cell function. So basically, like if you think of the cell as like a circle, we have these glycoproteins on the outside of the cell, and they're kind of like they're like a receptor so that they can receive information from other cells and allow the cells to have good communication amongst themselves. And part of that receptor is made of sugar. So again, we need to have sugars in order for that process to happen and for our cells to be able to then communicate with each other. Carbohydrates are also going to be a key element in RNA, which is going to help us with building of things within the body. So RNA is going to be important in order for us to have that building process occur, because it kind of has like the instruction manual for those processes. Okay. So the forms of carbohydrate that we have, most simplistically put, we have glucose and glycogen. Okay, glucose is kind of like a simple sugar that's kind of floating around, ready to go, ready for us to use. And glycogen is more like our storage form. And glycogen, think of it as like many glucose molecules that are like linked together, and then we will store those like as think of it as kind of like a strand of beads. Okay, so the glycogen is like a strand of beads that we can store, and glucose is like each individual bead is just kind of floating around, ready to be used. Okay, so where is glucose? We have glucose kind of floating in the blood, as I mentioned. We have about 8 to 10 grams of glucose floating around. And the brain uses glucose at a rate of 4 to 6 grams per hour. So again, you can kind of imagine that we're kind of constantly taking sugars out of storage, putting them into the blood in the form of glucose so that we have the right amount available for not only brain function, but some of those other unique functions that we've talked about. Okay. Um, for glycogen, we have 75 to 100 grams of glycogen stored in the liver, and we have 300 to 400 grams of glycogen stored in the muscles. Okay. And again, think of this as kind of like a long strand of beads, with each bead representing one glucose molecule. We'll link those all together, and that will allow us to kind of store those in these various locations. Total amount of calories stored in the form of carbohydrates is about 1,800 to 2,000 calories in total. Okay. So within our sugar, I guess, classification, we have something known as monosaccharides. Mono means one. So our monosaccharides are single sugar molecules. Okay. And we have three types. We have glucose, fructose, and galactose. In our intro unit, we talked about how these chemically look pretty darn similar, right? So here you can see from a chemical perspective what the glucose, what the galactose looks like. Again, notice how similar glucose and galactose are. Fructose is a little bit different, but still pretty darn close. Okay. So basically, we'll consume glucose, fructose, and galactose within our diets, and then we are going to be able to convert them eventually all into glucose. Okay, so glucose will serve as our primary source of energy for human cells. However, as I mentioned, we'll eat both fructose and galactose in our normal diets, and then be able to like convert those within our bodies. Okay. So fructose is a fruit sugar, and so this is going to come from, lots of different sources, but anything that's kind of fruit-based, for example. And after absorption, so after we kind of break down the food, like let's say we ate an apple, okay? After we chew up and digest that apple, we're going to carry those molecules from the digestive tract into the liver, okay? So after absorption, those molecules are going to be carried to the liver, and the liver is going to then convert those fructose molecules into glucose, or we can convert it into fat if we have like an overabundance of glucose or other sugars. Okay, so again, even if it's an apple, we can actually convert it into fats based on the overall quantity of sugars that we've consumed. Okay. Galactose is a milk sugar, and after absorption, same gig, this is going to be carried to the liver, and it will also be converted into glucose or glycogen. Okay, so glycogen was our storage form. Glucose is kind of like those singular beads that are floating around ready to be used. So both fructose and galactose will go through some processing at the level of the liver in order for us to get those into a usable form within the human body. Okay, next we'll take a look at disaccharide. Di means two, so disaccharides are two sugars linked together. Okay, so sucrose is made up of a glucose and a fructose molecule, and this will be found in sugarcane, honey, and syrup, and also kind of your simple sugars like white sugar, brown sugar, and powdered sugars. Okay, and here you can see kind of how these are linked together. So you have one glucose, one fructose molecule, and together they're known as a sucrose. Okay, lactose is going to be found in milk or dairy products. And this is two molecules composed of a glucose and a galactose molecule. So here you can see the glucose and galactose molecule are linked together in order to form lactose. So people that are lactose intolerant, for example, aren't able to break down this disaccharide. So there's an enzyme known as lactase, and lactase, its job is to break these two molecules apart so that I have a simple glucose and a simple galactose molecule. Well, people that are lactose intolerant either don't produce lactase or they produce it in small quantities, which means that they're not able to like effectively break down this molecule. Okay. And then lastly, we have maltose, and maltose is made of two glucose molecules linked together. We'll find this like in alcohol and products that are fermented. Otherwise, it's part of a more complicated chain of molecules that might be linked together to form polysaccharides or more complex chains. So multiple sugars that are kind of linked together, and more to come on that here. So as I mentioned, complex carbohydrates are long chains of sugars, so more than 10 sugars that are linked together. And we have polysaccharide. Poly means many, so it's greater than 10 sugar molecules linked together in order for us to create this long chain. And then starches are going to be found in plants, and plants are going to store glucose in the form of a starch. So again, a starch is just simply the plant's version of what we have as glycogen. So it's just their storage form of their sugars, and we consume that when we eat plants. So for example, you'll have a lot of starches in like potatoes. Sweet potatoes, regular potatoes are great examples of like a plant or a vegetable that's going to contain a large amount of starches. Okay. So when we think about carbohydrates, right, this is a macronutrient that is very commonly overconsumed. Okay, so when we think about the top carbohydrates in our country, I just think this is super interesting. The top carbohydrates are the top sugars that are consumed in the regular US diet. Number one is bread. Number two is soda. So when we think soda, not diet soda, I'm talking like Pepsi, root beer, any of those sodas that have calories, those are all simple sugars in those. Number three is added sugars that you would find in sweets. So whether that be cookies, cupcakes, cake, pie, those types of things, candy, all of those contain added sugars. Number four is potatoes and pastas, and number five is cereal. Okay, the average U.S. consumer has about 330 calories per day for males in the form of added sugars, and 270 calories per day for females in the form of added sugars. Okay, so again, these are things kind of above and beyond something that has kind of a regular sweetness level. So think about like, coffee creamers with sugar, that type of stuff, or things that are processed that contain those added sugars to increase the taste of those elements. Again, we're spending a lot of calories on kind of some of these extra things within the average United States diet. So what carbohydrates do you eat? Again, as we're kind of going through this class and you're doing your nutritional analyses, I want you to take a look at, what are you consuming? Are you over consuming some of those sugary beverages, whether that be, fancy coffee or energy drinks or pop or wine or mixed drinks like a rum and Coke, right? So are you over consuming sugars in the liquid form or something along those lines, right? Are you getting quality sources of sugars? So think like your whole wheat breads, oatmeal, brown rice, fruits and vegetables, right? So thinking about how can we make sure the sugars that we consume are quality, right? Because my goal here is not to tell you that sugar is bad, right? Sugar is not bad. We said that we need sugar for a lot of unique processes within the body. This lecture, I want you to focus on, am I getting those quality sources, right? So am I kind of focusing my diet around good quality options in terms of these sugars? And A lot of times when we talk about sugar or talk about carbohydrates, fiber is a common kind of like a little side street to talk about. Okay, so when we think about fiber, um, fiber is very biochemically similar to a carbohydrate and its chemical structure. However, like we don't really quite understand what's up with fiber. So basically, it's like it kind of looks like a sugar from its biochemical perspective. However, we can't necessarily digest or absorb it. So it will move through our digestive tract and it can kind of help us to clear out like biomes and create like good gut health within the small and large intestines. And that's why fiber is good for us, is because it makes us feel full, but we're not actually getting any calories from it because we don't actually absorb it. But you'll find this in like fruit skins, yogurt, seaweed, whole grains, beans, potatoes, all of those kind of like major players in good general healthy options for foods. You'll find a high amount of fiber. Okay. So, why is fiber good for us? People that get the recommended daily allowance of fiber have an increase in colon health. They have a decreased risk of obesity. And again, the connection here between weight management and fiber is that we're consuming this probably alongside some other healthy options in terms of calories. And it's going to make us feel full and stay full for longer in comparison to choosing like simple sugars that have no bulk from that fiber with them. Number three, it'll enhance blood glucose control. So when you consume foods that have a high fiber content, it kind of gives us a slow release of the sugar within that item, because that fiber is going to kind of slow down that digestive and absorptive process. So that's good. So you won't have a big spike in sugar and then a drop in sugar. You're going to just kind of have a nice gradual increase in sugar within your blood. So that's good. And then also it can help us to reduce cholesterol absorption. So again, because it's kind of this bulky substance that is going to be consumed with other elements, it's often we see that cholesterol isn't going to be absorbed at that same high rate as what it might be if we didn't have any fiber alongside. So lots of benefits to consuming fiber regularly. So how much fiber do you need? The RDA for women is 25 grams and the RDA for men is 38 grams, okay? Not to be consumed with what we are actually doing, right? So the average female is consuming about 13 grams, but the RDA is 25, okay? So we should be getting 25. We're getting about half of that. Men, same gig here. We should be getting 38. We're only getting 17. So we're about 50% in terms of what we should be getting. And again, I would encourage you as you're reflecting on your own diet to try to hit this standard. You know, when I work with people who are interested in weight loss or improving their nutrition, things like that, for me, it seems more fun to think about what can I add to my diet to add value? Well, this is a perfect example. Okay, so if I can add more fiber to my diet, that seems like more fun than me trying to restrict something or trying to limit something. And it turns out if we try to add more fiber in our diet, that's going to leave us less room for maybe some of those unhealthy choices like Cheetos, cake, that type of stuff, right? So by simply thinking about this, reframing it in your mind to, I need to hit this fiber guideline, right? That will allow us to kind of focus in on some of these healthier options to hit this standard as opposed to thinking about how can I eliminate these other things that I like. How much carbohydrates do you need? Okay. So the RDA recommends a minimum of 130 grams, and that minimum of 130 grams is, I think, really, really easy to eat. Easy to hit. I can hit that in breakfast alone. So 130 grams, because again, 1 gram is about 4 calories. So, if you have 130 grams, you're looking at what's that equal? About 500 calories. That's not too hard to hit. Okay, so that's the bare minimum. And the reason that we need to hit that kind of that bare minimum of 130 grams is that's going to allow us to fuel the red blood cells in the brain. Again, remember from earlier in this unit, we talked about how those two places in the body have to have carbs in order to function. So by hitting this 130 grams, that will kind of allow us to meet that minimum. Okay. Average intakes are significantly higher than that 130. So 200 to 320 grams per day for men and 180 to 230 grams per day for females. Okay. It ends up being about 45 to 65% of your total calorie intake. Okay. Carbohydrate needs, again, thinking about refined sugars that are added to foods during production. We talked just briefly about added sugars and how the average person is consuming about 300 calories of added sugars per day. But we want to have no more than 10% of our total calories coming from these added sugars. And again, you can check out on your label here, on your nutrition label, it will include a section where it has those added sugars listed. And we want to try to avoid or minimize that number. Okay, so in the next section of this unit, we're going to talk about how carbohydrates are digested and absorbed. Okay, so again, for each of the units, for each of the macronutrients, we're going to look at how are they taken in, moving through the digestive tract, absorbed, and then also manipulated so that we can utilize them for those energy pathways. Okay. Now, appreciate that all of these things will actually happen all together, right? So if I had a bagel with peanut butter for breakfast, that contains both sugars, proteins, and fats. Okay. And so while I'm talking right now about just what's happening with the sugars that would be found in the bagel, know that simultaneously I'm also going to break down the proteins and the fats. Okay. So all that stuff's kind of happening all together. There's a lot going on, right? So we'll kind of tease it out separately within each of those macronutrients, but do appreciate that this is all happening all together at the same time. So we got a lot going on, which is awesome. Okay. So here you can see in the color, we've got the digestive tract. Okay, and so here you can see we'll bring the food in through the mouth, then it's going to move through the esophagus into the stomach. Okay, and from the stomach, it'll move into the small intestines, which are found here, number 6. Okay, and into the large intestines or the colon, and those are going to move ascending to transverse to descending to sigmoid, and then out the anus for the waste products. Okay. Other things that are important to note about the digestive tract are some of the accessory organs. So we have the liver, which is a big old guy. You can see the liver here is number 3. The liver actually weighs like 4 pounds, so it's like freaking big, and it does like over 500 different things. It's like pretty cool freaking organ. Then you got the pancreas, which is shown here in green. Pancreas is a little bit smaller, but that's going to be important for carbohydrate breakdown. It also has some endocrine function, so it's going to like have some hormones being released and kind of monitored there as well. We have the gallbladder, which, where is that? This is that little blue guy here. The gallbladder is like a little sac, and that's where we're going to store an enzyme known as bile, and bile is going to help us with the breakdown of fat. So that's more is coming there about that. But yeah, this just kind of gives you an overview of kind of what that digestive tract looks like. So let's take a look at how we are going to break down carbohydrates. Okay, so first thing we're going to do, we're going to put the food in our mouth. So let's imagine something simple that's just sugars, something like Skittles. Okay, so I throw a handful of Skittles in my mouth and mechanical breakdown. I'm going to chew those Skittles, and the chewing process is going to allow me to chomp up those Skittles into smaller little pieces. At the same time, I'm also going to release something in my saliva known as salivary amylase. And the salivary amylase is going to start the breakdown of those sugars while they're in the mouth. So that's freaking cool. We're going to start digestion before we've even fully put the calories like into our body, which is kind of crazy. But you'll see that sugars are like super fast for us to digest and absorb and be able to use. So that's why we got to get it kick started right in the stomach. I'm sorry, right in the mouth. Next, we're moving through the esophagus. So that food is going to move from the mouth down to the stomach, and it's going to take the pathway of the esophagus. Spends a few seconds here, and then we're going to reach the stomach where we release a item known as hydrochloric acid. And hydrochloric acid is actually going to shut off carbohydrate digestion. Okay, it's going to change the acidity of the environment, and that's going to shut off that salivary amylase and cause it to denature or to break down, basically. And so, what we're going to do in the stomach is we're going to have some churning motion, and there's smooth muscle or like a small muscle layer surrounding the stomach, and it's going to cause like a churning sensation that will also help us with the mechanical breakdown of those foods. So not much going on in the stomach in terms of digestion of the chemical molecules of carbohydrates. However, we did have the mechanical breakdown going on through that churning process. And then we are going to move those molecules into the small intestines. And in the small intestines, we have three, well, really more than three, but three for our notes here, enzymes that are going to continue to break down those molecules. Okay, so if I started with a long chain of sugars, I've snipped it down into disaccharides or two bead little segments. Okay, so we have lactose, sucrose, and maltose of those little two segmented beads. And we have the enzymes lactase, sucrase, and maltase that are going to help us break down those disaccharides into monosaccharides. Okay, so we had two molecules linked together. That lactase, sucrase, and maltase caused us to chop the bond between those two. And now I have a bunch of singular beads kind of floating around as monosaccharides within the small intestines. And that is pretty much the end of the digestive processes for sugars. And the next thing we're going to do is something known as absorption. And absorption allows us to move those simple sugars, so those singular beads, from inside the small intestines to into the bloodstream. So we're going to allow those molecules to cross over the membrane in that process of absorption. And once they cross over that membrane, they're going to travel in a special like bloodstream via active transport and facilitated diffusion to the liver where they can be processed and then we can use them. Okay. There are some things that are unabsorbed and undigested. Okay, so we have some molecules that are unabsorbed, undigested, polysaccharides, also fiber. We talked about fiber being kind of similar to sugars, and so fiber along with these undigested molecules are going to pass through the small intestines into the large intestines. And once they reach the large intestines, that means that we are going to eliminate them. And this will become poop, basically, and they'll be eliminated through the rectum. Okay. So how are carbohydrates absorbed? So essentially we have two different mechanisms that we can use in order for carbohydrates to be absorbed through the intestinal walls. And essentially what we're doing is we're going to move the sugars from inside the small intestines to into the bloodstream. And these processes involve active transport and facilitated diffusion. Okay, so here you can see what's happening with active transport. And with active transport, we are going to move molecules against their gradient. Okay, so they're going to move kind of up their concentration gradient. So you can see here we have a lot of molecules and here we have a little. So think of these molecules as kind of having to like swim upstream as they cross over the membrane. And in order for us to facilitate active transport, we're going to need to invest some energy. So we're going to use ATP as our energy source in order for us to move these particular molecules. Okay. Now I want to kind of compare and contrast this with the other mechanism of absorption. So let's take a look. Okay, so here you can see what's known as a glucose sodium symporter. And with this mechanism, we are going to move glucose, sorry, that's a little bit blurry, and sodium, which is Na, together. Symporter means they're both of these molecules are going to move in the same direction. And kind of what's happening here is if I consume salt and sugar together, I'm able to move them faster, essentially, through this pathway. And in order for us to do that, we're going to require an energy input in order for this to happen. However, one thing that I think is important to note is that this channel is kind of open, right? So you can see this sugar just kind of being able to kind of flow through the channel so long as there's sodium available to do so. Okay. The other mechanism of absorption for our sugar molecules is known as facilitated diffusion. And facilitated diffusion you can kind of see here in image B, and active transport, or just a similar transport of that, can be seen in image A on the left side. And essentially the difference with facilitated diffusion is this is like a lock and key mechanism. So I have a molecule, it's going to come and sit inside of this like little chamber. The chamber flips over and we drop that sugar molecule onto the other side. Okay. So when we think about facilitated diffusion, this mechanism, because of this transformation of the carrier protein, this is going to take significantly longer than what we see with active transport. Okay, so our fructose is going to move through facilitated diffusion. So I always remember fructose, facilitated diffusion, they're both F's. And our glucose and galactose are going to move through active transport. So while active transport requires some sort of energy investment, it is significantly faster than what we see with our fructose molecules moving via facilitated diffusion, which is why, you know, fruits are a great example of a food that has a lot of fructose in it. And we know that when we eat like an apple, for example, we're going to get a slow spike in our blood sugar. So like if I have three small kids, so my daughters are 4 and my son is 7. And so if I were to give them an apple, we'd see a small gradual change in their blood sugar levels. If I give them the same amount of sugar in the form of Skittles, they go crazy. They're going to go nuts. And the reason for that is those sugars are going to very quickly get into the blood. They're going to be very quickly absorbed. And therefore, we're going to see like a change in their energy levels and they get all wild and crazy. So that's kind of why we see those differences when you consume fruit versus if you were to consume something like candy, which is going to use this mechanism a little bit more prominently. So, what are some of the implications when we think about sugars in sport performance? So, digestion and absorption of carbohydrates can occur very rapidly. So, sugars are kind of like I would say, is the easiest thing for us to ingest and get into our blood. It's the fastest form of calories that we can digest and absorb. So, sports drinks contain both sugars and sodium, which is going to enhance the speed of carbohydrate absorption and also helps with fluid retention because sodium is going to help us to hold on to water because it's hydrophilic. Okay, so high concentrations of fructose when we're in a sport performance realm, right? Like, so if I'm going to run a marathon, for example, it wouldn't be great to eat like an apple in the middle of that race because it's going to cause GI distress because it's going to be a slower digestive and absorptive process in comparison to something that's a simple sugar such as like Gatorade and things like that. So again, this is not me saying the apples are bad, right? We just need to be purposeful about when we use those. Okay. And the same is true with like Gatorade or, I mentioned sports drinks here. I'm not saying that those are good, right? If you're just sitting around and not really doing anything, they're a simple sugar and so they're not good for you, right? But if we're doing them in relation to sports and sport performance and we need to get those sugars in our system quickly, then that's a great option for us. So what happens next? So after we have absorption of these molecules, facilitated diffusion for our fructose and active transport for our glucose and galactose, we're going to carry those molecules through the hepatic portal system. And the hepatic portal system is simply a blood vessel system that's going to connect the small intestines with the liver. Okay, so it's like the specialized little channel that's going to carry the nutrients from the small intestines to the liver. Once we get those sugars to the liver, we're going to convert them all into glucose. So we'll take the galactose, we will take the fructose, and we're going to turn those into glucose molecules. Okay. Then once we have everything in the form of glucose, we can do a couple things with them. We can store them in the form of glycogen, or we can release them back into the blood in order for us to use them for whatever metabolic activity that we're doing at that time. So again, once we have that glucose in the blood, we can have that delivered to different cells upon need, and that'll be through a process of facilitated diffusion when we have insulin. Okay, so basically, like a little summary here, we eat the sugar, it goes through the stomach to the small intestines. We'll absorb it, and absorption is the movement from the small intestines into that hepatic portal system. The hepatic portal system is like a special blood tube that's going to carry those nutrients to the liver. Once they get to the liver, we'll convert those into sugar. Once they've turned into sugar, or glucose is our kind of our most simplistic form of that, we'll put them back into the blood. And once they're in the blood, they can travel all over the body. Okay. And if I have insulin available, insulin is going to help me to put those sugars into each of those cells as it travels throughout the blood. Okay, so we don't want to have a high amount of blood sugar. We don't want to have a big change in blood sugar. So we're constantly putting them in the cells so that we can store them, or we're putting them in the cells so that we can use them for energy. Okay, so three different fates of our sugars. We can use them for energy. We can store them in the form of glycogen, or we can convert them into fats. So if we consume like a lot of sugars, like let's say we had a big bag of Skittles, for example, okay, maybe I'm going to use some for energy right away. I'm going to top off my glycogen stores, or the storage form of sugars, and then whatever's left, I'm going to convert that into fats. Okay, so here we're looking at insulin. And insulin is kind of interesting. Insulin is a hormone that we're going to pay a lot of attention to, because it's in charge of monitoring how much sugar we have kind of floating in the blood. So if you can imagine that this is a cell, I'm going to have an insulin receptor. And once insulin binds to the receptor, it essentially unlocks the door. And once the door is unlocked, then glucose can enter into the cell. Okay, the glucose can only enter the cell, however, when insulin unlocks that channel. So another mechanism that's interesting to kind of think about when we think about sugars and think about carbohydrates within our diet is something known as glycemic index, or GI. And the glycemic index tells us how rapidly a substance reaches our blood as glucose. And the reference food is often glucose or white bread, and this is given a value of 100. Okay, so foods with a high GI are going to be very quick to get into the blood. Foods with a low GI are going to be more of a slower absorption and a slower digestive process. Okay, so foods that are going to be higher than 100. So white bread is kind of our standard at 100. Like Skittles might be 180, Twizzlers might be 145, right? So again, frosting might be 167 or something. I'm just making these numbers up, but that's just some examples of kind of simple sugars. Okay, an apple might be 72. Oatmeal and raisins together might be 65. Okay, so again, they're kind of all graded on this scale. So would it be better to eat foods with high GI or low GI? The answer when we think about general health is low GI. Low GI is going to allow us to have a slower digestion and absorptive rate, which would prevent us from overeating. And it also allows us to gradually modify our blood sugar, as opposed to when I eat Skittles. I know I'm using Skittles a lot as an example, but they're freaking good. Skittles are awesome. They are going to give us a large spike right away in blood sugar. So ideally, for us to maintain homeostasis, maintain like good general health, we want to kind of have just a gradual release of sugars into our blood. So what are some factors that affect GI? Okay, so the food form, including particle size due to processing, texture, viscosity, and the presence of soluble fibers. Okay, so let's kind of stop here for a second. So, okay, if I were to eat an apple versus applesauce versus apple juice, okay, so all three products come from the same item, right? So all three of those products are going to come from an apple. Okay. Oh, let's throw in like like a homemade baked apple pie. Okay. So again, even though they started as the same product, each of them is going to have a different GI. Okay, so the more food processing and cooking that we do, so if I were to cook my apple slices and put them into a pie, they will have a higher GI value than that raw, fresh apple, because when you process and cook them, it breaks down some of those chemical bonds, making it easier for us to digest and absorb those molecules. Okay. The presence of fructose or lactose. So again, if I were to eat plain oatmeal versus oatmeal with yogurt kind of mixed in it, the oatmeal with yogurt mixed in it is going to have a lower GI in comparison to the oatmeal on its own. And the reason for that is the proteins and fats that we find in yogurt, or the lactose that we find in yogurt, will slow down the process. The amount of starches will also play a role, starch protein and starch fat interactions. So again, like if I were to eat just a plain bagel versus a bagel with peanut butter on it, the bagel with peanut butter will have a lower GI because I have to also, while I'm breaking down like the sugars or the carbs within the bagel, I also have to break down the protein and fats that would be found within that peanut butter as well. Okay, so again, the quantity and quality of your overall meals will play a large role in determining the GI value. What are some of the concerns that we see with using GI? GI is used very regularly for people that are diabetics. And again, they want to kind of have low GI foods normally, and then maybe they want to have high GI foods if they get into trouble from a blood sugar perspective. Some of the concerns, this may vary from individual to individual. Okay, so again, what is the GI for me when I eat an apple versus what's the GI for you when you eat an apple? That can vary slightly from person to person. It doesn't take into account the amount of carbohydrates consumed or what's known as glucose kinetics. So, for example, I just went for a run this morning, and when I get home, if I'm going to eat an apple or a bowl of oatmeal or something, glucose kinetics means like I'm probably able to move those sugars really quickly from like the liver to the blood into my cells so that I can use them, so that I can refuel what I just burnt, because I was hungry right after, right? If, oh, sorry, a bird just flew right by me and landed. Um, if I were to eat like a second bowl of oatmeal after I had a first one, I didn't go for a run today, right? That's going to play a role in determining how quickly those sugars can move from place to place based on the needs, right? Supply demand. Okay. This will only indicate how rapidly the food ingested will appear into the blood as glucose. Glycemic load might be a better indicator of what's happening from a metabolic perspective as it relates to these sugars, because not only does it indicate how quickly, it also indicates how much. So it's basically the GI, and then we're also going to consider like how much. Okay, so did I have half a cup of oatmeal or did I have 2 cups of oatmeal? So it tells us how much, and so this would be a more useful indication of what's happening from a glucose metabolism perspective, because not only do I know how fast, I also know that total quantity as well. So what is the metabolic fate of blood glucose? Okay, so again, foods with high GI will lead us to have high glucose levels kind of immediately after, known as hyperglycemia. And again, this was the example that I gave. If I gave my kids Skittles, their blood sugar is going to just jump right up because they're little people and they're very good at getting those sugars into their blood. Okay, so hyperglycemia is any blood glucose level above 140 milligrams. If I had too much insulin, this can lead to a rapid and excessive transport of glucose into the cell, and this will lead to hypoglycemia. We can also experience hypoglycemia as part of fatigue as well. So if I was doing exercise, this might also happen. And hypoglycemia is going to be below 40 to 50 milligrams. So foods with low GI lead to slower insulin response and more stable blood glucose levels. So, how is hypoglycemia related to fatigue? So, if blood glucose becomes low, we just replenish that from the storage form of glycogen that we have, whether that be in the liver or in the muscles. So, during high intensity exercise, the rate of gluconeogenesis cannot keep up with the pace of glucose utilization. So, what the heck does that mean? Okay, so essentially, when we think about high intensity exercise, think about I'm using sugars like as fast as I can, and I can't produce more sugars fast enough, basically. Okay, so gluconeogenesis is the production of new glucose. So it's basically like when I take those sugars out of storage and turn them into blood glucose. However, if I'm doing high intensity exercise, like I'm spending more dollars than I can get out of my savings account, basically. So hyperglycemia or hypoglycemia can cause a disruption of the central nervous system and cause us to experience feelings of fatigue and, could cause us to feel dizzy or disoriented, those types of things, because I'm not getting enough sugar to the brain. So how is low muscle glycogen related to the development of fatigue? So again, if I'm thinking about spending my dollar bills basically as those sugar molecules, if I have low muscle glycogen, I'm saying that I don't have enough money in my bank account for me to buy those pair of jeans or buy that sweatshirt or buy that fancy coffee or whatever, right? So again, if I don't have enough in savings or in storage, this is going to make me feel really tired, right? So muscle glycogen is our major energy source for prolonged exercise. And if we cannot maintain exercise intensity above 85% without having the right amount in storage, we'll see a decline in our performance or in our ability to be able to do that exercise. So, what effect does endurance training have on carbohydrate metabolism? So, endurance trained muscles use less glucose and low and moderate exercise, but have a greater capacity to use more during high intensity exercise. So, again, essentially what we do is something called glucose sparing. And so, when I become very fit or highly trained as it relates to endurance work, so like, running or cycling or soccer, for example, I'm going to hold on to my sugars and wait for high intensity exercise because I know that I have a limited amount of them. Okay. And in the end, that would allow me to do more work than what I was able to do as an untrained person. Okay. So this would allow us to like really focus on using fats as our fuel and save those sugars for later. Okay, so more glycogen can be stored in the muscles as well, meaning that I can increase the amount of storage within my savings account. So, how does eating carbohydrates before or during an event improve our performance? So, if we were to eat sugars 4 hours before exercise, this can help us to top off our savings account or top off those glycogen storages. If we eat 5 to 10 minutes prior to exercise, again, this doesn't have to be a lot. This can be like one Gatorade or a granola bar, a banana, something like that, something small like that. That would allow us to increase our blood glucose levels so that that sugar is just ready to go. We've got like more cash available basically, so that we can spend that kind of right away. And then if we consume sugars 15 to 45 minutes post exercise, that's going to help us to kind of replenish our savings account based on how much we spent during that exercise bout. So when we think about dietary carbohydrates and health implications associated with such, the typical American diet is high in unhealthy fats and unhealthy carbohydrates. So the health effects of various sugars and starches are not in the substances themselves, but rather in the nutrients that accompany them. So again, it's not necessarily that carbohydrates are bad, it's all the other things that come along with the Skittles that are bad, right? I'm not saying that sugar is bad. I'm saying that the chemicals, the red dye, and the excessive quantity that we might consume and the effects that it has on like our blood sugar right away when we eat those things, that's the problem. It's not that sugar is bad. It's not that fats are bad. It's not that, any singular type of calorie is bad. It's kind of all the other factors that kind of lead us to believe that it's bad, if that makes sense. So, how do refined sugars and starches affect health? So, just a couple things to kind of think about here. Dental health, we see a link between dietary sugar and tooth decay. So, I'm sure you've heard of this before. If you eat a lot of candy, you might get a lot of cavities. So, tooth decay is not necessarily a matter of how much sugar one eats, but in what form and how often and like at what time of the day. Like, you're not supposed to eat some of those like soft, chewy types of candies or juice or anything like that, like before bed, because that sugar can kind of like sit on your teeth. Or if you do, you need to then also drink some water afterwards and brush your teeth afterwards. We also know that there's a relationship between dental health, heart disease, stroke, and diabetes. So not only is it cool to like have teeth and have your teeth look white, but also we see a link with other some of these general health concerns as it relates to our dental health. Chronic disease. So, a lot of refined dietary sugars can be linked to obesity, cancer, hyperactivity in children, PMS, and seasonal disorders as well. So, we see kind of a lot of sugar as kind of a bad thing in a lot of these different conditions. What about artificial sweeteners? So artificial sweeteners are products that are designed to provide sweetness but have little to no calories. And a lot of debate here. So should we have, a lot of researchers are asking like, you know, the idea here was like, okay, if I drink Diet Coke instead of regular Coke, I'm using these artificial sweeteners in the Diet Coke, and so I'm going to consume less calories in comparison to if I have the regular Coke. So then the Diet Coke would be healthier, is kind of the idea here. However, um, we're not necessarily seeing that because when we consume these artificial sweeteners, it sends an immediate signal to the brain like, hey, you got something sweet, you got that sugar, now you don't need that anymore. But it can actually lead to stronger cravings later in the day. Okay, so if I have a Diet Pepsi for lunch today, that might make me crave cookies, brownies tonight because even though I told my brain that I got this sweet fix, I didn't actually fulfill that because it was an artificial sweetener, not a true satisfaction of kind of that desire, if that makes sense from a physiological perspective. And so, therefore, we see people kind of overeating later in the day. So, there isn't any research that links the use of artificial sweeteners with like a reduced body fat or reduced body size or anything else like that. Again, I would say it's all about balance, right? So again, kind of thinking about how you want to spend your calories and kind of what you want to focus on in terms of improving your overall health. Um, and then, we can think about why are complex carbohydrates beneficial for our health? So complex carbohydrates, so we've got sweet potatoes, we've got some dark leafy greens like spinach, broccoli, oatmeal, like a whole wheat bread, fruits. So all of those are good for us. If consuming, when I think about my diet and I think about how to improve my diet, I want to think about these things and how can I add more of these into my diet. And as a result, that's going to reduce my contribution of some of these things because I'm just not going to have enough space to be able to also consume those. Okay. So again, these simple carbs, I've got donuts, gummy bears, French fries, like a Pepsi or a Coke, the simple sugars, all of those things. Over consuming those puts us at risk for cardiovascular disease, obesity, diabetes. So thinking about how can I maximize these complex carbs will by default then help us to then minimize these simple carbs. And then also, fiber. So we mentioned that fiber is one of the most widely underconsumed nutrients in our country. And here we can see a nice list of a bunch of fruits and vegetables that are going to be high in fiber. So again, thinking about how can we include these in our day-to-day lives so that we are kind of hitting the mark there. So again, thinking about how can I get enough fiber as opposed to thinking about how to eliminate certain things is maybe a better approach in the long run in terms of creating a healthy lifestyle. All right, that's it for today. I hope you have a great day, and we will see you next time.